Okay, so this is video 2 of your chemical analysis. You should have already watched the first video, so make sure that you've got that done. Let's go back here and find. Here we go. Your view is going to look different than mine. I'm on a Mac, so it might look different. Same content. I am not going to go through the quick checks. I'm going to let you guys do that because the explanations are there after the fact. So when you pull it up in the presentation mode, you can hit enter to find out your answer. Okay, ketone. Ketone is going to be the next pad on the on the dipstick from glucose, bilirubin, ketone. Now, we have already talked about urobilinogen, and urobilinogen is 60 seconds, but it was important to talk about bilirubin and urobilinogen together. But ketone is the third pad on the dipstick, and that method is sodium nitroprusside. 40 seconds, you grade that 0, negative, which is normal, trace small, moderate, large, or you can semi-quantitate it with the 1 + 2 + 3 +, etc. Significance of this shows that the patient is in an acidotic condition, such as diabetic ketoacidosis. There could be pancreatic disorders, malnutrition, starvation, etc. Oftentimes, ketone goes hand in hand with glucose. So the reagent on the dipstick is nitroferricyanide. Its sensitivity is as low as 5 milligrams per deciliter of ketone. False positives are like everything else. If the urine has a dye to it, it could impede or obscure the positive results. And for a false negative, an improperly preserved sample could be the culprit. If your sample is not properly capped, ketones can evaporate because ketones are volatile. They're just like alcohol. It evaporates very quickly. So you want to make sure that you provide instructions to collectors to make sure they cap the urine tightly. And you will find one of the most common problems in the transportation of samples via a tube system is the fact that the collectors cannot get the caps screwed on correctly. I can't overemphasize, I don't understand why we can't screw caps on correctly. I'm thinking it's just because they're in a rush, they're not paying attention. So again, attention to detail. We overanalyze everything we do. That's why we are med techs. And your ketone correlates with glucose, okay? There are 3 ketone bodies that your body can produce: acetone, beta-hydroxybutyric acid, which we talked about a little bit in the glucose chapter of chemistry, and acetoacetic acid, which is derived from both. Now, it's important to know that the reagent strips measure only acetoacetic acid. Beta-hydroxybutyric acid is not detected, neither is acetone, but acetoacetic acid is derived from both. So regardless if you have a condition that's producing beta-hydroxybutyric or acetone, your dipstick should pick it up because that acetoacetic acid is a byproduct of both. All right, specific gravity. Now, we could measure specific gravity with a refractometer. We talked about that in the first video, but the dipstick pad will actually let us pick it up as well. And it is the dissociation constant of a polyelectrolyte in an alkaline medium. Woo! What a crazy, that's basically a fancy term for pH, okay? 45 seconds, your result is going to be anything from 1.000, which is the equivalent of water, all the way to 1.030. So you just want to make sure you get the color of that reaction pad as close to the comparable color on your bottle when you're measuring it. Now, specific gravity is an indicator of how well your nephrons are concentrating your urine, and it also is an indicator of your hydration state. So if your urine is like neon orange and maybe you haven't had water in like 2 days, yeah, your specific gravity is going to be off the chart. It's going to be very high. Now, if you've drank water 24/7 and you're about to float away, your specific gravity is probably going to be close to 1. Don't do either of those conditions. It's not good for you. The method is polybromthymol blue, and it's actually an acid-base indicator. There's your sensitivity. False positives are ones that could have a high concentration of protein and or glucose, meaning that there is a ton of both in each. And we talked about correcting for that in one of the previous videos. Highly alkaline urines could give a false negative result, but I really haven't seen much of that. Now, the pads that should correlate with this are glucose and protein. So if you have a positive glucose and a positive protein, you should expect to see a higher specific gravity because there's more molecules of each dissolved in your urine. Therefore, you're going to have more particles in your urine, and it's going to drive up that specific gravity. And this is an image of actually how the reagent strip detects the changes in the number of electrolytes. So polyelectrolyte just means that there are numerous ions, and we're looking at the positive and the negative. So if you have more of a alkaline pH in your urine, it's going to turn it to a blue-green, whereas if you have a more acidic, more hydrogen ions, you're going to see the yellow-green. So the alkaline equates to more negative, and the pink equates to more positive. So it's not important that you know that. What it's important is that the actual specific gravity is detected through measurement of the number of electrolytes, more than one type, in urine. Okay, so let's talk about the difference between specific gravity on a strip and in a refractometer. The pros of this: the reagent strip's obviously easier to use, it's less labor intensive, it's disposable. The refractometer is going to give you a more quantitative result, and the refractometer is reusable. The cons is that the reagent strip gives you an estimate of specific gravity, not a more exact number. And the refractometer can be easily misread. It must be cleaned after each use, and if it's not dried, it's going to give you false results. Hence, we don't use refractometers hardly anymore. So you're going to be familiar with them, and I believe I've got a few, but we're not going to go deep into the refractometer. Okay, the blood pad. So this is the actual activity of the blood in the presence of hydrogen peroxide and a chromogen that will cause a color change. You have to wait 1 minute for this one, and your results are just like the others. Negative is normal, trace small, moderate, large, or you can semi-quantitate with a trace 1 + 2 + 3 +. And obviously, if you have a positive, that's an indication that you have blood, hemoglobin, or even myoglobin in your urine. It will detect all three. So what's the difference? Hematuria is the presence of intact red blood cells, and that can give you an indication that you might have some sort of irritation in your urinary tract. You might have stones, you might have an infection, or you might have some sort of trauma to your kidneys that's causing an active bleeding. So these are intact red blood cells. Hemoglobinuria is when you have hemoglobin in your urine that is not contained within an intact red blood cell. Situations that can give rise to this are severe burns, hemolytic anemias, and transfusion reactions where your glomerulus is actually filtering out that hemoglobin that has been released into your system. And then myoglobin is actually a byproduct of the breakdown of muscle tissues. So this comes from muscle trauma, can come from drug abuse, extensive exertion, etc. And we talk about myoglobin a bit in chemistry, so it'll be nice to cross-reference both of these. So hematuria, intact red cells, hemoglobinuria, free hemoglobin in urine, and myoglobinuria is when we have myoglobin in urine. And these are examples of what the samples would look like. Your blood reagent pad, here's your long name here. Like I said, don't worry about that. Your sensitivity, it can detect down as low as 5 red blood cells per milliliter and even lower concentrations for hemoglobin. Your false positives, we could actually have situations where there might be peroxidases that have been secreted by organisms that could cause a false positive. And then menstrual contamination is a big one we see. The false negatives, oftentimes if you have urines that are highly concentrated in nitrites, which we'll talk about in a minute, you could see a false negative in that. It would obscure the results. And as with a lot of things, vitamin C in high concentrations can cause you problems. Now, blood is made up of proteins, right? So if you think about what could connect with other pads on the strip, protein. So if you've got blood in your urine, you should expect to see protein. Now, that doesn't mean you will, but you should expect it. pH. All right, so we use methyl red and bromethymol blue that is actually impregnated into the strip. You wait a minute, and it will read anything from a pH of 5 all the way to 9, with 5 to 8 being quote unquote normal. Usually your urine pH is more from 6.5 to 7.5. And the reason that we test pH is because we can actually see if the body is adjusting for the physiological pH within itself by either retaining hydrogen ions or excreting hydrogen ions. So we look at acidotic or alkalotic conditions. This can also show us renal stone formation, and it can give indication if the sample is acceptable, because if the pH is very, very high, let's say 9, that might indicate an old sample, which would be unacceptable. Okay, so here's your information on the pH strip. The false positives. There's really no known interfering substances, but you want to make sure that you are careful when you blot the strip, because pad run over from chromogen from other pads could actually obscure the results. And the same thing for your false negatives. Now, what correlates with pH? Nitrite and leukocytes, especially nitrite, because when you have bacteria in your urine, the more that they metabolize carbon and nitrogen that are present, the higher the pH is going to rise. So if you've got, let's say, E. coli and it's in your urine, and you've got a positive nitrite, you've got positive leukocyte because you've got white blood cells in your urine, more than likely that bacteria is engaging in metabolic activity, and the byproducts of that metabolic activity will drive the pH of the sample up. So that's why we correlate that. Protein. All right, protein. We call this protein error of indicators, and what we are testing for in the urine dipstick is albumin. So the test time is 60 seconds, and the results can span from negative to 4+, and we use this to look for various pre-renal to post-renal conditions. Specifically, if you have protein in your urine, there's a good indication that you have had renal damage. So, causes of protein in urine: pre-renal, renal, and post-renal. Now, when we're looking at pre-renal conditions, we're talking about conditions that affect plasma protein prior to that blood reaching the kidneys. This could be something like inflammation. So if you've got an autoimmune disorder where you're creating more antibody and you're causing a systemic inflammatory process, that could be an indicator of a pre-renal condition. Renal damage, we're looking at literal damage to the nephron where the glomerulus is spilling out protein, and we don't want that. Remember, we don't actually lose protein at the glomerulus. We lose everything else and then reabsorb it, but we don't lose protein. So diabetes mellitus is an example of a condition that causes severe renal complications if left untreated. And also other exogenous compounds like vancomycin is one. You've heard of me talk about vancomycin in MLT240 as far as it being nephrotoxic. That's because it damages your tubular reabsorption processes, so you can't reabsorb specific compounds like you should. And then we've got post-renal situations like urinary tract infection that might be causing exudates of white blood cells or red blood cells. Those proteins can actually be picked up in the sample. And here is information on your protein dip. It correlates with nitrite, blood, leukocytes, and glucose. So it's very important. And it's pretty much, you can ask yourself this question: if the compound you're testing for, such as blood or leukocytes, contains protein, then it more than likely will pick it up. If you're spilling over glucose in large amounts, then more than likely you're going to spill over protein as well. So they correlate with protein. So when you see a positive protein, you want to make sure that you think about what other tests could be positive. Nitrite. Any shade of pink is considered positive. And the method is reduction of nitrate to nitrite. So we're actually converting a compound to another. It's 60 seconds wait time, and negative is normal. This indicates actual bacterial infection. So this is your bacteria pad, and the problem with this is not all bacteria reduce nitrate to nitrite, but the real clinically significant ones do. So, for instance, E. coli, you would see a positive nitrite in your urine for E. coli. And here we go. So it's a reduction pathway from nitrate to nitrite to nitrogen. There are some organisms that are so powerful, they'll reduce nitrate all the way to elemental nitrogen. If that happens, it's a negative pad, okay? That doesn't mean that it hasn't done it. It's just the reaction's negative. So even if you think you should have gotten a positive nitrite and you didn't, that doesn't mean something went wrong. It could be that the bacteria is just that powerful that it reduces it all the way to nitrogen, or that it's not a nitrate reducing bacterium. Here's your information for nitrite. And like we've talked, it should correlate with other tests such as protein and leukocytes. And leukocyte esterase, the pretty purple pad. So this actually looks for an enzyme that is secreted by the organism. So it's an enzymatic action of leukocyte esterase in the presence of an acidic compound and a chromogen that will produce a purple color. You do have to wait 2 full minutes for this, and it's graded from negative to 3+, with negative being normal. We look at this as an indicator of white blood cells in your urine. It could be bacterial or non-bacterial urinary tract infection. And it's important to know that mononuclear cells such as lymphocytes and monocytes do not secrete leukocyte esterase. Very important. And obviously, we're looking for a correlation between protein and the bacteria that reduce nitrite. All right, I'm going to let you complete that. And if you literally click through each one, I believe it should pop up for you. But we'll go over this in lab as well. And we talked about this last week. I would like for you to take a look at that video, and I'll make sure that the link is working. So it's dip, drag, blot, and place or read, okay? So when I say place, I'm talking about placing it in an analyzer test strip well. And I will try this week to see if we can use our little urinalysis reader and see if that works for these dipsticks. I'll try that tomorrow. But in the event, you're doing it manually, because you have to do it manually. And you'll thank me later when you go into your big labs and you see all these texts that are like, I don't know how to do it manually. How do you do it manually? You're like, whatever. Dip, drag, blot, and place or read. Okay, performing the urine dip. Points to remember: properly dip and drag the strip. You want to make sure you blot the strip. Don't blot the top of the pad. Blot the side of the pad so you're taking off excess urine so that that urine doesn't spill over and cause a bleed of color into another pad. And you want to make sure you accurately time the strip. Don't place it and then come back 2 minutes later and start reading it. You dip it, drag it, blot it, read it right at that time. So that's really important that you start the reading at 30 seconds, because if you don't, you're going to get erroneous results. So we're going to keep practicing this every week, and you're going to find that ad nauseum you're going to be like, I don't want to do this anymore, and I'm going to say, go do more. We're going to stop this video right here, and let's see how many slides we have left. Okay. Yeah, we're going to stop this one right here, and then we are going to talk about the confirmatory tests actually in lab, because those are ones that we don't do that often. So there won't be another video posted online until after the first lab, and we'll talk about the confirmatory test and finish up the rest of this PowerPoint. Thank you.